Hello my dear student, today I am going to show you one of the most important part of the chapter, that is structure of atom. Structure of atom. The part is Niels Bohr atomic model. That is Bohr's atomic model. Bohr is a scientist and he proposed his atomic model earlier in the 1885. So that is Niels Bohr atomic model. In Niels Bohr atomic model, he said that in a particular atom, there must be a discrete number of orbits. That is called cell. So that is, if we focus on the atom, there must be a number of electron, number of proton, number of neutron also are there. And neutron is electrically neutral, proton is positive, and electrons are negative, as you know. So in that case, if we emphasize that there must be a particular atom. So in an atom, there must be a nucleus, and in that particular nucleus there is number of proton and number of neutron. So number of proton are equal to number of electron. That's why nucleus is electrically neutral. So there is number of neutron is actually a electrically neutral compound, and proton is electrically positive. That's why there is a proton, and the proton and neutron are in the core of the nucleus of a particular atom. So Niels Bohr atomic model, he proposed his postulates. So what are the postulates? He said that in a particular atom there must be a discrete number of orbit or cell. So in a particular atom there are number of discrete orbit or cell, and in that discrete orbit or cell the electrons are revolving. That is, it's specifically important for the electrons, and electrons are revolving in that particular orbit or cell in a particular atom. And the second postulate is that while revolving in the atom and revolving in between the actually called the cell, that is cell is actually a circular cell, it's neither emit energy or neither accepts, but it can probably in the future it's going to accept energy going to the upper level and lower level. It's next concept. So in that case, it said that according to Niels Bohr atomic model 1885, he proposed that there is discrete number of cell or orbit, and in that revolving in the particular cell or orbit, it neither radiant energy. So while revolving, it's neither radiate energy. So in that particular case, we must say that it's neither radiate energy. So that is, there is a number of orbits, that is discrete orbits like the circular orbit. So we have to propose the electrons are revolving around the particular nucleus. So how many electrons will revolve, and how the number of, we should find it out, that is the number of electrons revolving. In that case, we have to assign it, that is a different kind of cell name assigning, that is called K cell, this is L cell, this is M cell, this is N cell. So actually this is N cell is like the way it's not particularly circle, so we have to make it proper, so that is it's getting a proper circle. Okay, so in that case we have to say that this is for K, that is, it's the formula that is called 2n square formula. So in that n equal to 1, that is K cell, n equal to 2, that is L cell, n equal to 3, that is KLM cell, and n equal to 4, that is N cell. So in that case, for 2n square formula, if you put it out, that n equals to 1, so it gives you 2n square, that is number of electrons is 2 for the K cell. Isn't that correct? For n equals to K cell, that is the number of electrons revolving. For 2 into 2 square, that is 8, so this is L cell. For 2 into 3 square, that is 18, that is called M cell. For 2 into 4 square, that is number of electrons is 32, so that is called N cell. Okay, so in that case, now the electrons are revolving like the way. That is for K cell there is number of electron is 2, that is 2 cell, that is like the way there is must be a 8 electron. So this is number of electrons should be an 8. So 1, 2, 3, 4, 5, 6, 7, 8. Like the way 18 is the next, like the way 32 is the next, and continuously in so on. So in that case, this is the basic formula we must need to show the number of electrons are revolving around the particular nucleus. So taking an example. Suppose we take in an example such as neon. So neon is actually number of electron is it's 10. Number of electron 10, number of proton is actually 10, and there must be a number of electron 10. As you know, neon is actually a noble gaseous element. Okay. So it is a noble gas element. So there must be a number of electrons should be 8 at the last cell according to the valency. So every atom is trying to attain the number of electron in the last cell is 8. That is called octet rule. We will later know about the octet rule. Okay, so that is the important part. So that is number of electron is 10. So if we assign like the way in atom, so like just the way this is the nucleus. Actually I am taking positive because proton are there, so that's why I am taking it positive, and number of electron that is the cell. So as we know number of electron is 10. So in the first cell there must be a 2 electron. So we have to assign it 2 electron are there in the K cell. And then 8 number of electrons are left 8. So 8 there must be a L. So that is we have to assign 8. That is 1, 2, 3, 4, 5, 6, 7, 8. So neon is complete. Now I am taking sodium. Sodium is 11. So it's like the way up to it's going to neon, just like the same way. In extra electron is 1, so that is going to the M cell. So that is number of electron is here. If we go into magnesium, that is 12. So that is like the way it's continue to the M neon. The number of electrons are left 2. So that is again its M cell. For aluminium, that is 13 M cell. Silicon 14. Phosphorus 15, sulfur 16, oxygen, sulfur 16, and fluorine 17, and argon 18. So that is 18 is complete. Okay, so that is number of electrons in a M cell. It must contain number of electron maximum contain 18 electrons. But actually I am given example how the number of electrons are revolving around the particular atom according to Niels Bohr. Like this is the way of the formula. Okay. Hope you understand this. Thank you so much.